Hello friends, welcome back. So in this video we will see the definition of joint density function and then its properties. In the last video we have seen joint distribution function and its properties. So like for the single random variable case, the density function fx of x is nothing but first order derivative of the distribution function. Similarly, here also the joint density function, joint density function is defined as the second order second order derivative of the joint distribution function, second order derivative of the joint distribution function, second order derivative of the joint distribution function. It is denoted with fxy of x comma y, so which is nothing but dou square differentiation with respect to x and with respect to y, the joint distribution function. So this is the expression for joint probability density function, or in short joint density function. So coming to the property, first property, fxy of x comma y is always greater than or equal to 0. Second one is area under the joint density curve. Area under the joint density curve. So this property is very useful to verify whether the given function is valid density function, or to find the constants in the given density function. This property is very useful. Area under the joint density function is 1. So here also we can get the marginal density functions. Marginal density functions are, that is fx distribution function, marginal distribution function. We can get, if we want x, we have to integrate from minus infinity to x, whereas y values are minus infinity to infinity. The joint density function dx comma dy. And similarly, if we want the marginal distribution function of y, now x values are from minus infinity to infinity, whereas y values are from minus infinity to y. fxy of x comma y dx dy. And similarly, we can get the joint distribution function fxy of x comma y by simply integrating from minus infinity to x minus infinity to y fxy of x comma y dx dy. So this is another property. So if you want the probability of x taking values between x1 and x2 including x2, and similarly y taking values from y including y2, we can get by simply integrating x1 to x2, y1 to y2 fxy, that is the joint density function. Between these values, if we integrate, we will get the probability of x lying between x1 to x2 and y lying between y1 to y2. And the last property, we can get marginal density functions also. Marginal density functions. Marginal density functions from joint density function by integrating, for example, if we want the marginal density function of x, we have to integrate with all values of y the joint density function. The joint density function we have to integrate with respect to all values of y. Similarly, if we want marginal density function of y, we have to integrate from minus infinity to infinity for all values of x. All values of x. If you want function of y, we have to take all values of y. If we want the marginal density function of y, we have to integrate for all the values of x. So these are the properties of the joint density function, and this is the expression. So if we differentiate the joint distribution function twice with respect to x and with respect to y, we will get the joint density function. So this is the definition and these are the properties. So I hope you are able to understand the definition and its properties. If you have any doubts, please enter your doubts in the comment section. Thank you for watching. Please subscribe to my channel and share with your friends and classmates.